Greetings, dear participants of the conference. I am Smailov S.F from Sevastopol State University. The topic of my presentation is UK mechanical keypad with RGB lighting. The device was developed to order. The customer provided the following required parameters. To case, minimum input lag, using of mechanical switches, dimension less than 40 to 60 to 35 millimeters, RGB lighting with several modes of illumination, and relatively low cost. Microcontroller selection. Used microcontroller can work as heat device, so there were such options. Atmel Atmega 32U4, STM32, Atmel ATtiny 85. STM32 is the best microcontroller from them in the price-performance ratio, but it is very powerful for our purposes, so was chosen the ATtiny 85 microcontroller. About this MK. Its operating frequency is from 1 to 20 MHz. It has 6 digital pins. 2 of them will be used for USB interface. It has 8 kilobytes of flash, 1 pin for hardware interrupts, supply voltage from 2.7, 5.5 volts, and it is the cheapest microcontroller from presented on the slide earlier. Next. Cherry MX mechanical switches. This is a very common type of mechanical push-button switches now. They have many types of them with different actuation stroke and pressing force. Iceland the number of clicks over 15 millions or 50 millions. Pressing force from 40 grams, actuation stroke from 1.5 millimeters, and were easy to buy. Where at the slide you can see the view of these switches, how they work. Also there is a graph where you can see force and switch travel. Next slide. Addressable LEDs WS2812. For lighting will be used these LEDs. They use only one digital pin for data transmission, and they are cheap and easy to buy. Also, supply voltage is from 3.5 to 5.3 volts. After the choosing the components, was developed an electrical diagram of device. The device will be powered via micro USB. There you can see 2 microcontrollers. First will be for key pressing to one microcontroller, and second will be for lighting. Also you can see the capacitor C1, it used for power smoothing. Also there are 2 Zener diodes, D1 and D2. There are for stabilization of microcontroller. Where it is? Key program. For key program was used Cricket Hit combo library. It can realize holding a key, which is very necessary for our device. For a microcontroller which is responsible for keystrokes, bounce suppression is optional, since all modern computers have a built-in anti-bounce system. Backlight program. For the backlight program was used NeoPixel library. There was realized 5 types of RGB lighting. First is RGB off. Second, third, and fourth are smooth inclusion of red, green and blue. Also, there are two rainbow types. First is rainbow cycling, and second is rainbow cycling, but every LED has its own color. Also, for microcontroller used for RGB backlighting, it's necessary to exclude bounds, as this will be lead to multiple changing of operating modes of backlight with a single press. So, was added a program method of bound suppression, where you can see it. Next, after that was designed a PCB, where you can see upper layer and the bottom layer of PCB. And there are the graphs where you can see 3D view of our board. There are two microcontrollers, two switches, one key for changing the backlight mode, and one USB port. Let's go to the conclusions. All necessary requirements are met. Response speed was minimized and it is about 10 milliseconds. The size of the device is 32.8 millimeters to 48 millimeters. Bounds of context does not interfere with operation of a device. Also, were added 5 modes of backlight. Half of microcontroller's main memory remains, so we can add a few more modes. The most expensive components are mechanical switches, where cost varies greatly. The cheapest are around $5 per 10, and the board itself. Other components cost less than $5. Also, in the future is planned to develop a software that will allow to recycle keys and create a change backlight modes. That's it. Thank you for your attention.